Hello, grade 9s. We are now starting our next unit. It is more linear relations. So this is good. If you did well in the last unit, I think you'll do quite well in this unit. And if you struggled in the last unit, this is sort of more opportunity to improve on what we've been learning so far. So I'm not going to do a first 5-minute question today. Instead, I'm going to just jump into it. I'm going to do the first example, and then I'm going to leave 2 examples for you, and we'll just keep kind of bouncing back and forth. So this is in your handout. So here it says a scientist measures the temperature as it decreases. So whenever you're doing this stuff, if you see the word increases or decreases, those are important words to take note of. He takes a temperature reading every half hour. So then we have a table of values here, and we've got time on the left and temperature on the right. So let's go through the questions and make sure we can do those first. So what is the independent variable? Well, the independent variable is always the thing on the left of the table, so that's going to be time. And then the dependent variable then would be the temperature. And again, this is review from last unit, so hopefully it's not too difficult. And if it is, just get in touch with me. I'm happy to host a Google Meet for one person or a bunch of people, whatever works. So to find the rise, we want to know what happens from here to here. And to do that, we take the bottom number and we subtract the number above. So in this case, we have -5 minus -4, and that is going to be -1. Now the other way to do this is just to look at the numbers. If you go from -4 to -5, are you going up or down? And in this case, you're going down by 1, so the rise is -1. And for the run, we do the same thing, but we do it with the x values, or the values of the independent variable. And we take the number below, 0.5, and we subtract the number above. And in this case, we get 0.5. Okay, so the run is 0.5. The rate of change, we've done it a bunch of times. It's the rise divided by the run. So we take the number for the rise, -1, and we divide it for the number for the run, which is 0.5. And then I actually go to my calculator and I do this. So -1 divided by 0.5 is -2. Okay. For the initial value happens when x is 0, and the initial value is the y value when x equals 0. And so in this case, it's going to be -4. Okay? Finally, to write the equation, we have, it's always in y equals mx plus b form. But in these real-life situations, we replace the y and the x with letters from our variables. So the y value, remember the y values are always over on the right here. They're the dependent, so it's going to be temperature. So I'll say T equals, the m, remember, is the rate of change, which we found here to be -2. And then where there's an x, that's going to come from the independent variable. And we could use T for time, but we already used T for temperature. So let's use H for number of hours. And then it's going to be plus B. B is the initial value. In this case, it's -4. So if you wrote plus -4, you'd be correct. But usually we don't write plus minus because if you're adding a negative, you're just subtracting. Okay, so that's it. That's this whole question. And then what I have for you, I believe, is I have 2 examples, the movie rental example, and I have the study time example. So I'm going to go through the movie rental example, and I'm going to get you to try the study time example. So first we're going to find the equation. So we need the rate of change. So we do the rise, and that's going to equal 5 minus 3, which is going to be 2. And then we'll do the run, which is going to be 2 minus 1 equals 1. So the rate of change, equals 2 over 1, and if we divide that, we just get 2. Leaving it as 2 over 1 is technically correct, but usually we would just divide it if it divides nicely. Now for the initial value, this is a bit tricky because we need to know when the independent variable is 0, we need to find this number. So what you'll notice here is this is going up by 1, right? 1, 2, 3, 4, 5, 6, 7. So if we go back once, we go to 0. So as we go down, we go plus 1. And as we go up, we go minus 1. So now we've got to go the opposite direction here. And you'll notice as we go down, we go up 2, up 2, up 2, up 2. And if we go back up the table, we go down 2, down 2, down 2, down 2. And then from here, if we go down 2, so 3 minus 2 is going to be 1. So the initial value is going to be 1. And now we can write our equation. So again, these are our x's, these are our y's. Remember that it's always y equals mx plus b. In this case, the y's is the fee paid. So we'll say, fee, or f, equals, remember the m is the rate of change, so 2x, but instead of x, it's movies rented, so let's say m, or n for number of movies, that would be fine too, and then plus b, well, the initial value we found is 1, so plus 1. And that's it, that's the equation. So now we're asked, what does this ordered pair mean? Now an ordered pair is just a point, so don't let the crazy terminology scare you. This is our x value, this is our y value. And if we come over here, we see that our x values is movies rented. So this means 20 movies rented. And then our y value is our fee paid. And in this case, 20 comma 41, that would mean fee paid is $41. That's all that means. Okay? And then on to the last part here, if you paid $337, how many movies did you rent? So in this case, $337 is the fee. So I go back to my equation, f equals 2m plus 1. And what I'm going to do is I'm going to take this 337 and I'm going to plug it in for f. So 337 equals 2m plus 1. And then I'm going to solve for m. And this is something that we did in our solving equations unit way back when. So to solve for m, we got to get m by itself. So the first thing is we get rid of this plus 1 by opposite operations, so we subtract 1. 337 minus 1 is 336 equals 2m, because this has been canceled out. And now the 2 and the m are multiplying, so what's the opposite of multiplying? Well, it's dividing. So we divide by 2 on both sides. These cancel out, and we get m equals 336 divided by 2, and it's 168. So 168 movies. So if you rent 168 movies, that's a lot of movies. It's going to cost you $337. Okay. I'm going to leave this example for you to do. It's very similar to the last one. Okay. And notice here it says, careful, the initial value isn't on the table this time. Okay, moving on. Now we're going to do equations from word problems. Again, this is just a recap from last unit. So it costs $100 to join a golf club, and then $15 for every game that you play. We're asked for the variables. I start with the dependent variable because it's the easy one, and that's like, what do you want to know? In this case, you want to know the cost. And I'll put the units, just because. And then the question is, what determines the cost? Well, if we read this again, it costs $100 to join a golf club, and then $15 for every game. So the independent variable in this case is number of games, because as you play more games, the cost goes up. So to find the independent variable, you just have to figure out what changes the cost. And in this case, the number of games you play changes the cost. Okay, initial value, rate of change. So it costs $100 to join. That's the initial value, right? It's a one-time fee. It's what it starts at. And then $15 for every game. So the only other number is 15, so it's $15. Remember, I put per game to get my units in there. Now we're asked for an equation. So to get the equation, remember it's always y equals mx plus b. And the y is our dependent variable, so it's going to be cost equals. The m is the rate of change, which we said is 15. The x is the independent, so let's say number of games, n for number, g for games is fine too, and then plus b, so plus the initial value, which is 100. Just like that. Now we're going to use the equation. So how much would it cost to play 14 games? So I rewrite my equation, and all you have to figure out here is 14 games, is that going to be our n or our c? So is this a cost or is this a number of games? Well, this is a number of games. So I take that number, the number of games in this case is 14, so I sub in 14. And then all that's left from there is to do it on your calculator. So we do multiplication before addition, so 15 times 14 is 210, plus we have to add the original cost of 100, and I get $310. So it costs $310 to play 14 games. And the next question, how many games did Jim play if he spent $340? So you could figure this out a few ways. I made it easy enough that that would work, but I want you to do it this way because sometimes you're going to have to do it the hard way. So he spent $340. This is his cost, right? So I sub in $340 for the cost. And now I'm going to solve for the number of games. So to get n by itself, I have to get rid of this 100. I use opposite operations. We have plus, so I do minus. So I get 240 equals 15n. And finally, the 15 and the n are multiplying, so I divide by the 15 to get rid of it. Right? Don't divide by the 240 because you want to get rid of the 15. So n equals 240 divided by 15 is 16 games. And if you look at the answer here, it makes sense, right? 14 games is 310, 16 games is 340. So this question here, this is about as hard as this stuff is going to get right now, so make sure you practice that. Okay, so I got another example here. I'm going to let you do this example. Okay. Let me see what I got left here. It's going to go back to your handout. So I did this one, I want you to do this one. I did example 1, I want you to do example 2. And let's look at example 3. So create a table, create 2 equations. Okay, so I'm going to do Kevin's, and I'm going to have you do David's. Okay, so let's go page width. So Kevin and David are hungry boys. They begin with a pile of candy, and they snack and snack and snack. Kevin starts with 50 candies. So right away, I know that at time 0, Kevin has 50. And he eats 5 every hour. So let's go 1 hour, 2 hour, 3 hour, 4 hour. So if he eats 5, starts with 50, how many does he have left after an hour? Well, you do 50 and you subtract 5, right? So this is minus 5. And then we go down 5 again to 40. And then we go down 5, we go down 5, and I get 35, and then 30. Now, you might be wondering why I put in these minus 5s. Well, it's the same reason I'm going to put in this plus 1. Because this gives us the rise, and this gives us the run. And so when we make our equations, this is going to make it very, very easy. So create 2 equations. So let's do Kevin's. So for Kevin, our y is candies left, so let's say candies equals, and now we do our rate of change, which is going to be negative 5 over 1, which is just negative 5, so negative 5, and then our x in y equals mx plus b is time in hours, let's say h for number of hours, and then plus the initial value. Kevin starts with 50, so plus 50. I'm going to leave David's equation to you. And finally, use your equations to find out how much each boy has left after 7 hours. So again, I'm going to do Kevin, and I'm going to have you do David. So c equals negative 5h plus 50. And for this question, we've been asked about 7 hours, so I'm going to plug in 7. plus 50. So negative 5 times 7 is negative 35, plus 50 is 15. So Kevin has 15 candies left after 7 hours. Okay, so again, I'm going to have you do David's table, equation, and solve when H is 7 hours. Okay, next up. Through a series of experiments, the scientists discovered that a piece of cheese has 40 bacteria on it to begin with, and that 24 new bacteria appear after each minute. So first of all, remember we've got y equals mx plus b. This is what it starts with, so this is our b, and this is what it changes by, so this is our m. Okay? So we want to find out how many bacteria. So let's say number of bacteria is b equals m is 24, so 24x. Well, what's our independent variable? Well, in this case, it says each minute. So let's say m for number of minutes, and then plus what we started at. Okay? So after 4 minutes, after 4 minutes, we sub in 4 for m, so just like this, and then we add 40, and b equals 24 times 4 plus 40, 136. Okay, so this is the easy type, and down here is the hard type. So they have 304 bacteria, so let's start with the equation. How many minutes have passed? So in this case, we're solving for m, which means we have to sub in for b. So b is 304 equals 24m plus 40. And just like before, it's always the same, right? You're going to find these are really repetitive. We got to subtract that 40 to get the m by itself. So 304 minus 40 is 264, is 24m. And finally, we divide by 24 to get m totally by itself. So 264 divided by 24 is 11. 11 minutes. Okay, and that's that. Example 2, I'm going to leave this to you. Example 3, I'm going to leave this to you as well. Example 4, again, this is going to be homework. Example 5, let me get the handout. Example 5. I'm going to show you example 5 because there's a fraction in there. So I'm going to rewrite the formula. 9 over 5c plus 32. So this is a Fahrenheit Celsius equation. It helps you, like, if you know one, what's the other? This is a real-life equation that you would use if you were converting temperature. And if you have Google do a temperature conversion, this is what it's doing. So it says here 86 degrees Fahrenheit. So that means that 86 is F, and we're asked the temperature in Celsius, so we have to solve for C. Now again, this is tricky. That's why I'm showing you how to do it here. So to get C by itself first, just like before, we subtract 32. 86 minus 32 is 54, equals 9 over 5C. Now this is hard because this C is being multiplied by 9 divided by 5, so I'm going to rewrite this as this. 54 equals 9C over 5. And just know that that's the same as this. Okay? That's how fractions work. So if we're going to get rid of this 5, which I want to do, it's dividing, so we multiply on both sides, as always. This cancels out, and we get 9C equals 54 times 5 is 270. Now notice I could have written 270 equals 9C, but it's the same thing. I divide by 9, and I get C equals 30 degrees Celsius. So if you ever hear someone say it's 86 Fahrenheit outside, you'll know that that's 30 degrees Celsius. Okay, so that's it. That's all I have for today. Again, it's mostly review from last unit. I'm going to give you an extra question here that I really want you to do. And it's going to be just like what we just did, but now it's going to say, if it is 100 degrees Fahrenheit, what is that in degrees Celsius? So that is just the same as this question, except for you're going to plug in 100 here instead of 86. All right, folks, please don't hesitate to reach out if you want some help. Try these questions, do your best, and let me know if you want to set up like a Google Meet that I can go through the questions with you. I can share my screen, you can share your screen to show me what you did, and I can show my screen to show you how to do it. Good luck.